Okay, so I decided that I was going to print out some of the homework questions directly as they kind of look with the hints from the CPM online assessment, just to see whether or not my information was valid along with what they had down. So on number 18, I'm not going to go through all of these, but I'm going to set up number 18, and then you can do B, C, and D also. On number 18, okay, it says, use a process you developed in 4-13 to factor the following quadratic expressions. So we have just a heads up and an FYI. Please get into the habit of putting a 1 in front of your x squares, because that will come in hand when we have to actually do the diamond setting. So I'm going to fill these in. So we have 1x squared, and we have -12. Okay. And then we know from the multiplying along the diagonal that whatever answer when we multiply in the diagonal goes at the top of the diamond. So we have, let's see, 1 times -12 should give you -12x squared, because the x squared comes with you. I'm going to zoom in. And then whatever answer we get has to add up to -4x. Okay, so now you have to ask yourself the question, more importantly, is the numbers. What two numbers, when you multiply together, give you a -12, but when you add them up, you get a -4? And I'm hoping that we get, let's see, -6x and 2x. So -6 times 2 is going to give you -12, but when you add them up, you're going to get it with the -4. So just put them in. So -6x here, and then +2x there. Okay, and then from here you should be able to finish out your product. So you have an x and an x, because you have to get an x squared. 1, so 1 and 1. I'm just putting the ones in. If you guys don't want to put them in, that's fine, but if you get them wrong, don't say I didn't tell you so. And then you have, let's see, we want a 2x, so we pretty much have a 2 here. And then -6 here, because 1 times -6 is going to give you that -6, and then -6 times 2. Have to verify that the last one works. It's a -12. Okay, so as a final answer, your product is, let's see, 1x minus 6 and 1x plus 2, right, because it's a +2. Okay, so that was a review, and a really fast review, I should say, of what we hopefully did in class today, and you were paying attention. So B, C, and D you're on your own with. I just did 18A in case you needed a refresher on where the numbers come from. All right, 19, I'm going to draw a picture for you, and hopefully it'll actually help, because I'm not going to do the work, because you should know how to do tangent ratios, but I will draw a picture, because sometimes those are a little bit better than anything. So I'm going to use the picture in the book, because it actually does help a little bit. I'm going to draw this out. So let's see. So her eyes are, let's say she's here, right? And then her dad is probably a little taller than her. Okay, and they're really skinny people. And it says she had to look up, right, into her dad's eyes. There you go. She looked up into her dad's eyes, and then she is, let's see, standing 15 inches away from her dad. Okay, so she's standing 15 inches away. Okay, so she's standing 15 inches away from her dad. And then she's also 32 inches above the ground. Her eyes are. So remember when we went outside to actually look at the gym, right? So she's 32 inches tall, I mean, up to her eyes. And the bigger question is, so this is, she's looking up and it's 68 degrees. How high above the flat ground were her father's eyes if Mary's eyes were 32 inches above the ground? Okay, well, if you don't see it, I'm going to color this in really quick for you. Your triangle is right here. Okay, so we have a wonderful right triangle at 68 degrees, and we know this is 15 inches. We don't know this part, but I'm sure that you can find it using your tangent ratio. And then the remaining bit is, well, it's 32 inches, right? So whatever you find, please don't forget to add it up to the 32 to get the total height of up to her dad's eyes. Okay, and then it has change in y over change in x set up for you. So what's your change in y, what's your change in x of your slope ratio? If you have issues with the calculator, your computer does actually have that function. Okay, number 20. You shouldn't have any issues plugging anything in. The only thing I would caution you is if you're substituting any value in for x squared, please make sure that you are actually putting parentheses around the value that you're substituting in. So, for example, on the first one, it's y equals, in parentheses, -4 squared. So that comes out to 16. So 16 is the first value for y. Okay, please don't forget the parentheses. And then when you're finished, you should get something that after you graph correctly using graph paper, something along the lines of that. Okay, it's not perfect, but it should match around there. And then it says, this is an example of a parabola. The vertex is the maximum or minimum point of the parabola, where the x is the parabola you graphed in part A. So since this parabola is actually going up, it doesn't have a maximum point because it really has a bottom point, which is the minimum. And this coordinate right here is 0, 0, which is what the answer is on the website, on the CPM website. Okay. And then 21, you need to calculate the expected value. I'm not going to help you do B, but I will give you a hint for, it says, what is the ratio or likelihood of landing a 30-degree angle and getting a 9? What is the probability of getting a 4? So the setup is from the expected value. So your entire circle should be 360. As far as I know, it's 360. Okay, that's 30 degrees from here to here. Or this angle is 30 degrees, I should say. It's pretty much the same thing. And then this part is going to be 330 degrees because 330 and 30 is going to give you your total 360. So then you can calculate it out. Your expected value is going to be 330 over 360 times 9 plus 330 over 360 times your 4. And you can do the math on that. And the question is, what's the expected value? So what's the value of getting a 4? What's the expected value of getting a 9? And then you're going to need to do the same thing with 12. Okay, and if you're still stuck, you can refer to the math notes page on in lesson 3.2.1 in your book. Okay, and then on 22, are the triangles similar? If you decide that they are, justify your conclusion using a flowchart. Okay, what do the two arrows mean? Okay, well, the two arrows mean, they're parallel. Okay, well, what do they tell you about the angle relationships? Well, it's more than just, first of all, I hope you recognize that you have vertical angles. You have an angle here and you have an angle there that are congruent because they are vertical. So, but more importantly, the angle relationships with respect to parallel lines. So, you have two parallel lines. Here's your parallel. Actually, I should do this in a different color. Here's your parallel line. Here's your parallel line. You have two transversals that are cutting across. Here's a transversal, right? Well, these angles in here are going to be congruent because they are, and I'm going to let you fill that in. And then you also have, just by chance, these angles here that are congruent because you have another transversal that's going through parallel lines. So you decide, why are the triangles similar? And your three options were either angle-angle similarity, side-angle-side similarity, or side-side-side similarity. Those were the three. Okay. Now, it says draw a flowchart. So you technically have to decide what it is that you want to do and then draw the flowchart. I'm not going to draw the flowchart with you because that will give you the hint on what the flowchart is supposed to look like. Okay, and then lastly, since they are similar, you can set up a proportion for the sides. So it actually helped the fact that I did this in color, because now you can see which sides are supposed to correspond to each other. So if you have 20 over x, 20 comes from the triangle on the left, x comes from the triangle on the right. 20 is in between the green angle and the pink angle, x is in between the green angle and the pink angle. Okay, well that's fine. So now use the other side. So 20, now your only option is to use 24. Okay, well 24 comes from between the pink and the purple, between the pink and the purple. Actually, it probably looks more like blue. So x plus 2 has to be on the bottom. Okay, and you can use whatever method your heart desires to solve for that. And I believe the answer should be x equals 10. I don't know. I forgot to look up the actual answer, so good luck with that one. Alright, but that's the setup for it. 24 and x plus 2, 20 and x. Okay, look at where they are positioned with respect to the angles. Okay. Alright, and then the last one, Larry saw Giovanna's incomplete Venn diagram at the right. He wants to finish it. However, he does not know the condition that the circle represents. Determine a possible label for each circle. Place 2 more shapes into the diagram. Okay, I'm having a heck of a hard time trying to figure out what this answer is, so I literally have to look this up because it's been bugging me all night, and I have no clue. I can tell what the left side is, but I have no idea what they want for the right side, so I actually have to look this up. What? Okay, so the left circle should be could be equilateral. Okay, that part I understand. The symbols on both of the shapes tell you that they're, at least the quality on this side is, name the shapes that are equilateral. Okay, so anything that is equal-sided should be in this circle over here. Okay, which actually works for us. That part's easy to see. The only problem I had was I don't understand what's supposed to be in this circle. It could be anything. Oh, that's lame. Okay, let's say maybe a quadrilateral. Really? Okay, I guess. So anything that's quadrilateral. So any four-sided figure. What do we have? Trapezoids, parallelograms, right trapezoids, kites, diamonds. Oh, diamonds! God, you guys are getting me saying. No, then wouldn't a rhombus go in there? Oh yeah, then a rhombus would have to go in there. Yeah, put a rhombus in there, guys. Okay, so kite is a quadrilateral. Rhombus would have to go in there because it's equilateral and a quadrilateral. Yes, actually, yes. And then the other thing is we have the square, right? Okay, and then, oh, rectangle. I forgot the rectangle. Okay, so those are the two. I hope that helps, because that was really vague. Even for me, that was really vague. Okay, I'll see you guys in class later. Take care. Bye.